Yay!
Yay! All right, so now let's take this 12 gauge wire, a 2 millimeter thick wire, and let's pretend it's like an extension cord. We've got 30 meters of it. So let's see, for the diameter of the wire, 2 millimeters, and the length of the wire being 30 meters, what is its resistance R? So what you do is, it depends on what it's made of. All right, so usually these things are made of copper. So let's say that it's made of copper. And so the relationship is the resistance of the entire wire is rho times L over A. It's kind of unfortunate they called it rho because in the last example, I think we used rho as density. But sometimes, most of the time when you see something like a rho, it's like some sort of density. But this is a different rho. It's too bad. And it's called resistivity. Rho is called resistivity. And it's just a constant. It's different for every metal. You just look it up in a book. So this is going to be for copper. It's like 1.72 times 10 to the minus 8th. And then my L, the length, is going to be 30. And then the area of this thing, let's see, the diameter is 2 millimeters, so the radius is 1 millimeter. So it's just going to be pi times r squared times 10 to the minus 3 squared is 10 to the minus 6. And so if I did, let's see, if I plug all these numbers in, what did I get? I got 0.16 ohms. The fundamental unit of resistance is ohms. So you kind of have to worry about this if you have, if you're trying to power something that needs to take a certain amount of amperage, and you're getting it from a voltage source that's constant, you know, from the wall or whatever. A really, really long extension cord is going to cut it down a little bit because the extension cords have some resistance. So sometimes you kind of have to take that into account. You have to worry about it. But that's all there is to it. If you want to get the resistance of a wire, all you need to know is what it's made of, its length, and then its area, how thick it is. And then you're all set.